Hello children, I welcome you all to this math session, and this is the fourth session for the fourth chapter, squares and square root. 4 is also a perfect square number. Okay children, every day we used to have a thought before we get into the session, and today for a change we do have a thought but it in a different mood. Come on, see this video and enjoy it. It's a rainy season and water has stagnated. This gentleman is very smart. He folded his pant and crossed that stagnated water, dirty water. And do you think he is smart? And now another man comes and he is smarter. Without disturbing that stagnated water, he crossed the pool. And here comes a smartest boy like you all people. What do you think he's going to do now? Come on. I believe you all people will do the same. Very smart. Isn't it, my dear children? He crossed it without getting dirt in him. Same way, our life is simple. Why complicate it? So this is the time of shutdown, a very tough situation, but let us see it in a simple way instead of complicating it. And our school has provided you stones like this to cross this pandemic and shut down through a digital mode of learning. Hope you will all enjoy it. Let us make our learning a happy one. Okay, let us recall the thing that we learned in previous classes. We started with squares, properties of squares. Then in previous class we learned two things. What are they? Yes, my dear children. First, Pythagorean triplet. It is a special because here also we do have squares. Okay. How to define a Pythagorean triplet? What is the general form to have a Pythagorean triplet? Yes, very good. 2m, m squared minus 1 and m squared plus 1. This m can be any natural number greater than 1. You may ask, ma'am, shall I substitute m to be half, which is less than 1? No, my dear children, you cannot, because as per this definition, m should be greater than 1. Is it clear, my dear children? We solved few problems using this Pythagorean triplet. Okay, then what did we see in the previous class? Very good. We learned to find the square root, the reverse process of squaring. Okay, by prime factorization method and repeated subtraction. Now we are going to have a recap of prime factorization method. Okay, to find the square root of 6400, it has to be splitted into factors. We all know the 64 can be written as 8 into 8, 100. This is 6400, isn't it? So I got 10 into 10. This is the simplest way of doing it. But you can also do using prime factorization method like this. 6400. You can start with, whenever you start doing prime factorization, it's a good practice to start with the prime numbers. This is the smallest prime number, 2. So we will have 3 2s are 6, then 2 2s are 4, then 0, 0. Isn't it, my dear children? Okay. As I proceed like this, I get all the factors like this. 2 into 2 into 2 into 2 into 2. How many 2s I have? 1, 2, 3, 4, 5, 6, 7, 8. 8 2s and 2 5s. To find the square root, I have to take square root. Isn't it? Here too I will have square root. Then instead of 2 2s, we will have 1 2. Here another 2 2s, 1 2. Then next 2 2s, another 1 2. How many pairs of 2 did I have? 1, 2, 3, 4. So I got 4 2s here. And 1 pair of 5. So when I remove it from square root, I have 1 5. If I multiply all these, I get 80 to be the answer. Here too I got the same answer. This is very simple and this is the proper way to do it. Is it clear? Be smart. You can use any method. Okay children, and today we are going to continue with the same prime factorization method, but something different questions. Questions are going to be something different. Shall we enter into the new session now? Okay children, here the question for you is, find the smallest number by which 9408 must be divided so that the quotient is a perfect square. With this question, can you say, is 9408 is a perfect square? Read the question again and tell me whether 9408 is a perfect square. Just by looking at the unit digit also you can say using the properties. Surely it is not a perfect square, my dear children. So I can make this as a perfect square either by dividing it or multiplying it by one or more factor or one or more than one factor. Is it clear? So this is not a perfect square, but this can be made into perfect square by dividing it. Here they have asked us to divide it. You may also get a question where this must be multiplied by. Instead of division, they may ask you multiplied by. So that the quotient is a, here if it is multiplied, they will say so that the product is a perfect square. There will be a difference. Divided means they will say quotient. If it is multiplied, they will say product. Okay, if I multiply, I get a product. If I divide, I get a quotient. Isn't it? Okay. Now shall we get into the solution? After converting it to perfect square, I have to find the square root of that quotient. Is it clear, my dear children? Okay, now let us get into the solution. Here, I start doing prime factorization for 9408. Okay. Starting from 2. 4 2s are 8. Carry 1. 7 2s are 14. 0. The 0 is not divisible by 2, so I have written as it is 0. 4 2s are 8. Again starting with 2. 2 2s are 4. 3 2s are 6. Carry 1. So 10 it becomes. 5 2s are 10. 2 2s are 4. Again 2. 1 2 is 2. 1 2 is 2. Carry 1. 7 2s are 14. Carry 1. 6 2s are 12. Is it clear? Again, this 1 is not divisible by 2. So I take these two digits together. I have 5 2s are 10. Carry 1. It becomes 17. 8 2s are 16. Carry 1. Again 8 2s are 16. If I do it with 2, I get 2 2s are 4. 9 2s are 18. And 4 2s are 8. Then 1 2 is 2. 4 2s are 8. Carry 1. 7 2s are 14. 3. In 3 table, is it divisible? How to check the divisibility? 7 plus 1, 8. 8 plus 4, 12. If I add the sum of digits, it should be divisible by 3. So it is divisible by 3. So I can say 4 3s are 12. Remainder 2. So 27. How many times 27? 9 times. 9 3s are 27. Then I have 7 7s are 49. Is it clear, my dear children? So I have got the prime factorization for 9408 and I have found all the factors of 9408. Now I have written the prime factorization of 9408 is equal to, count the number of 2's, 1, 2, 3, 4, 5, 6 2's. Have I written 6 2's here? 1, 2, 3, 4, 5, 6 2's and 2 7's and 1 3. Now it is not a perfect square. See, everything occurs in pair. except this 3. This 3 is not having its pair. So I can say it is not a perfect square. I should remove this 3. How to remove? Just erase it off. It's removing, isn't it? But it will not be equal to this 9400. If I remove this, if I multiply all the other thing, will be equal to 9408? No. So I divide it by 3. Now that's the question they have asked me. What should be divided? The one which is not occurring in pair should be taken as a factor that has to be divided. Is it clear? So I divide this 9408 by 3. It's very simple, cancellation itself. No need to go in for long division, you just cancel it. 3 3s are 9, 1 3s are 3, carry 1, 3 3s are 9 again, carry 1, 6 3s are 18. So I got 3136. And if I do the again prime factorization, no, it's same thing. Only 3 is missing. I will get all the other remaining factors as it is. You can do it in rough and find whether you get the same thing. So this 3136 is a perfect square. The required smallest number that has to be divided is 3. All these steps are very necessary and you have to write square root of 3136. They have asked you to find the square root of 3136, isn't it, my dear children? So you have to write 3136 is equal to, in pairs you have to write 1 2, again I have one more pair, so into 2, and another pair I have, so I have to write into 2, another pair I have. So what, multiply and give me the answer. What will be the answer? 7 2s are 14, 14 2s are 28, 28 2s are 56. Very good. You will have the square root of 3136 as 56. Here in all these problems, you can do it in reverse order to check your answers too. Okay, children. So let us get into the another problem. If they ask you to find what should be multiplied with this to make it a perfect square, I have to multiply one more 3 in extra. So at that time you will not divide, you will multiply and tell me the answer. Is it clear? Then you will multiply 56 into 3 also. So it will be a different problem. So you should know the difference. Okay, now let us get into the one more problem. Find the smallest square number which is divisible by each of the numbers 6, 9 and 15. It is 6, 9 and 15. I have to find the smallest number. Okay, which is divisible by 6. Is 12 divisible by 6? Yes, but it is not divisible by 9 and 15. Then what is the another multiple of 6? 18. 18 is divisible by 6. 18 is divisible by 9, but it is not divisible by 15. Next number, what will you say? You will find the multiple of 6 again. 3 6 are 18, 4 6 are 24. Again, it is not divisible by. How long will I go by this trial and error method, my dear children? It's not fair. And if it is going to be a very big number, it's again a tedious job. So, I am finding the multiples of 6, isn't it? I have to find the multiple of 9. I have to find the multiple of 15. Among all these multiples, I should find the common multiple. Common multiple. That will be divisible by all these 3. Isn't it? I have to find the multiple of all these 3 and I have to find the common multiple. Only then I can say it is divisible by all the 3. See, 27 is a multiple of 9, but it is not divisible by 6 and 15. I want a common multiple. So what should I find? Guess it. Common multiple. And I have to find that smallest common multiple. So what am I going to find now first? Very good. We are going to find LCM. Find the smallest. First we find the smallest common multiple. You all know to do LCM, isn't it? So 6, 9 and 15. After finding this common LCM, I find the number to be 90. And this is divisible by 6, 9 and 15. Is it clear? So this 90 is not a perfect square. I will continue in next video, my dear children. Thank you.